I thought I'd show you something interesting. Just a minute. I'm just updating everything. Did I get it all right? Yeah. All right. I'm still printing. It's not right. I'm just gonna flip this round. I thought I'd share this with you because it's something I saw the other day, and I thought maybe I should show you this interesting thing about my generator. Obviously, I've just wound 2 more coils up, but I haven't tried them yet. I haven't wired them up, but it's not that I want to show you. I want to show you something else. Right, I'll just get this moving because I don't want to stall it. Right, we're just going to do a little experiment. I think you'll find this interesting. Piece of nanocrystalline material. Okay, watch what happens. Another piece of nanocrystalline material. Bend it in an arc. Can you see anything? In the bottom? Alright, let's try a bigger piece. Nanocrystalline coarse material. There's quite a considerable amount of magnetic attenuation going on. Oops. Where's my torch gone? Oh, it's all on the floor. Right. Can you see that nanocrystalline core material down there? You see what it's doing? It's dancing. I'm going to disconnect the power. Well, what's interesting is you'll notice it doesn't actually follow the flywheel. When the flywheel stops, it does not follow the flywheel because the magnetic attenuation is pulsing on and off, on and off, on and off. It's not rotating all the way around the wheel, which is the whole point. Actually, I need my paintbrush. Where's my paintbrush? Oh, look at that, look at that. Can you see that? Oh, it stopped now. Right. I lost my paintbrush. Where the bloody hell have I put it? I wanted to move. Oh, it's here. I just wanted to move it a little bit. Let's get them other pieces out. Oh, what I'm going to do is I'm going to grab them other pieces. I'm going to stick a little magnet on the end of my on the end of my file because I want to get the other pieces out. Right, those are the little pieces. Take them out. Now, what's interesting, we get the big piece in a minute. Can't get the magnet off my file, it's been awkward. Right, so if I put the big piece here, right in the middle, and we move this. Right, watch that material. See? On, off, on, off, on, off. This is how my device works. It turns the magnetic field on and off onto the rotor assembly. It's not rotating. I mean, if the field itself was actually spinning, because the magnets are actually not turning, you see, the magnets are stationary. So this shows you exactly how it turns the magnetic field on and off to the coil, which means how can there be any drag? Look. Off, on, off, on, off, on. Right, you get it? Okay, I'm going to turn it on again. actually supercapacitors are too charged, so I'm going to turn the power off a minute because I want this to run down. I want the supercapacitors to run down so it's running slower so you can see it better. I need to get it started. Right. We'll just wait until the supercapacitors run down a bit. Won't take too long to run them down. I've turned the power off now, so it's running. It's just running off the supercapacitors right now. I want it to slow down. It's slowing down slowly. You can see the effect better at low speeds. Waiting for it to slow down and basically go really slow. I'm trying to bring it closer so you can see it better. Anyway, it's in the middle, which is where it needs to be. Right, it's slowing down. See, a normal magnet rotor with just magnets in the rotor assembly, it would cause that metal to follow the rotor and stick to the rotor and then follow the rotor around, but because it's pulsing, it's not actually rotating. The magnetic field is not a rotating magnetic field, it's an actuated magnetic field. And as we get slower, we should see it jump up and down like on a trampoline. Obviously it's going too fast now that it can't react fast enough. My rubber band wants some more white chalk on it because it's sticky. Yeah, I have got a flat belt. Somebody commented, a friend commented about why use a video recorder belt. I have got flat belts. They just had a lot of drag, a lot of friction. I've got the big belt and a small belt, and I've got some really long belts, which is what I used on my previous device, which is too long for this one. I could put the flat belt back on, actually. I might do that in a minute. Actually, let me do that now. Let me put the flat belt on. I'm just going to turn it off a second. Right, I'm going to turn it off. I'm going to put the flat belt on because this rubber band is really starting. Oh, let's just watch what happens as it comes to a stop. Right, I just want to get this rubber band off. Let's put the flat belt on. Right, the rubber band is pretty cruddy, but I wanted to run this in a bit, you see. Oops, I don't want to pull it over. Get on there. Right, hopefully I haven't knocked it out of alignment. Right, we've got the flat belt on now. Let me just start this up again. Go spin it a bit and start it. Right, we're on the flat belt now. So the stupid capacitors are slowly running down and running it slower. It runs slow for quite a long time actually, because it's not consuming very much power. As the speed gets lower, the power consumption drops off dramatically because there's less wind resistance, there's less drag. This is why I'm trying to optimize the generator to work more efficiently at slower speeds by having 3 cycles per 90 degree, that is from here to there, per 90 degree of rotation. By having 3 cycles, it means that I'll get more power per cycle. So in theory, with a full set of coils all the way around, that would be 12 cycles for 360 degrees. So that, well, 12 cycles, yeah, I think 12. 12 cycles of waveforms when you add all the coils together. But each coil would be getting 3 cycles. Each set of 3 coils will be getting 3 cycles. The way I would do that would be to buffer each coil with a capacitor, so that when the cycle gets to the 90 degree point, the capacitors have previously been charged up in the first 2 coil sets. It would release that energy. So I'll be using capacitors across my coils as well. Now you can see how it's actuated. That metal's starting to really dance right now. Obviously the piece of nanocrystalline material, it's got wind resistance to deal with, because as it moves up it's got to push air out of the way, and as it drops down it's going to push air out of the way, so it can't oscillate very quickly. And it's got its own inertial mass as well to overcome. Normally, as I said, normally with a magnetic rotor assembly, that would literally want to follow the rotor. It would stick to the rotor and follow it around. But it doesn't do that with this, because the way it's actuated. There you go. Anyway, I thought you'd find that interesting. It's fun to watch actually. So yeah, I've where's my buttons? Oh, look, that end. I'm gonna press them in. So there's I wound 2 coils on there. They're not very many turns, and I realise I haven't got my hooks big enough. The little plastic hooks that I wind the wire around on here, they're too shallow, so I've got a bit of SketchUp and I've made the hooks longer so they come out here, so I can wind a lot more wire on there, because at the moment I can only get a bit before it starts to slip off the edge. So I thought, another mistake. Well, yeah, you don't think of everything, do you? You make mistakes. So I'm going to be printing a new canopy later, but I'm going to finish winding this one. It's going to be for a test when I get that other stator magnet assembly printed. I can stick all the magnets in it, and I can at least have this coil set. I've got another coil to wind on here. Then I'll have this coil set as a baseline to measure against, and obviously using less wire is a good thing, because it means I'm not going to waste a lot of copper. So it's just for an experiment, this part. Before I make the final coil winding, I want to measure the voltages in all these coils to test the new magnet arrangement is working. So if I'm getting, say, voltage on this coil, a voltage on this coil, and the voltage on the coil that I haven't wound yet, I can work out roughly how many volts I will get if I have many more turns. So I didn't want to use all my wire up on a test, so obviously, because it means I've got to buy my wire. I can obviously unwind it, but it's every time you wind stuff you cut it and then you got to join it all back together again. I hate doing that. So anyway, yeah, I just thought I'd show you where we are at the moment. Thanks for watching. Should have an update probably tomorrow, because I don't know, it's getting late now. It's 1:30 AM. I don't think I'm going to be doing too much more tonight, really. Anyway, that's it for now.